Okay, tak apa. When you remove, then masuk balik. Remove. So it's okay. I will record for you guys, and then I'm going to upload it in the YouTube. So I'm going to put it on the YouTube, and then you can view the YouTube. This one, I think it will take less data of your data lah. So okay. Today we're going to respond on the chat. Something. So because yesterday I got a problem with this Google Meet. I cannot listen to the students' voice. So I want you guys to respond, and that was a very good discussion using chat. Okay, now if you have something, you just unmute yourself, or you can chat during this time. All right. When the question asks you to use basic law, we have several things that you can use in your basic law. So what is basic law? Basic law is something that I think you are familiar with, the Ohm's law, and then we have Kirchhoff. Kirchhoff have two types, the Kirchhoff current law and voltage law. And then we have another two, which is voltage divider and current divider. Just take note that maybe this is in chapter 2. You're still new to this electric circuit, right? But later on, you're going to go through chapter 3, which is the method, and also chapter 4. Some other methods of analysis. You're going to have several methods to solve the circuits. So if the question asks you to use only basic law, please do not use another methods in chapter 3 or chapter 4. This is chapter 2. So you use only basic law if they ask you to use basic law. So what are they? These 5. Okay. So I already write down here, and then you maybe later on you will get familiar with this thing. Okay. All right. And then in this chapter 2, we're going to learn on the sources in series and parallel. We have two types. And then the Ohm's law, okay, but we revisit this. And then there's some terms like open circuit and short circuit. This one I already introduced you in chapter 1. And then we have conductance, nodes, branches, loops. This is some terminology that you need to get familiar with, so that when they put it in the question, then you can answer. Refer to that definition. And then we have that Kirchhoff law of 2, which is current and voltage law. Then we have voltage divider and series for resistor, and current divider and parallel to that resistor. And then some Y delta transformation. Please remind me on this, because if I'm not mistaken, they want to exclude this from your syllabus, because we shorten our weeks from 14 weeks to 12 weeks in this semester. So this is already in week number 2. So if I'm not mistaken, they're going to exclude this Y delta transformation. So you are kind of lucky lah. And you please reconfirm with me, because I'm going to reconfirm with them. Okay. All right. So what is ideal voltage source? Ideal voltage source is that when you have a voltages in series, you can add them together. Remember our previous example, I think example number 1 in our lecture 1, we have something like this. VS, not VS, V of total. What is V of total here? When you have one dependent source here and another is the independent source. So they give you something like this. And what we did was, we look at the polarity of each, right? And this and this. If they are same, then you can just add without changing the sign. So basically V1 can be added with V2 because of the polarity is same. So ideally, a voltage source will give you exactly as it is. Like if you have this 5 volt, then it will delivers exactly 5 volt ideally. Okay, but in your real situation, you're going to have like 5 volt plus minus 0.1 or plus minus 0.01. So that one is a real case. You will not face like exactly 5 volt in a real world. Okay, so for your circuit analysis, this one will be treat as a ideal case. Okay, and then if we have a series, you know that series can be added. Okay, V1 plus V2, and then you have this V total. But what about the right side? There's some rules. If you want to have a voltage in parallel, remember last time we have this voltage and then some resistor, and then what is the V drop across this R1? Can you guess? Anyone? Okay, you can write down or unmute yourself. What is Vx equal to? This is Vx. Okay, please write down. We supposed to have like 54 students. Minus me, then this is only 51 students. I want to know who's absent. So you need to write down your answer or something in the chat room so that I know that you are in the class, something like that. So please write down in the chat room here. Well, what do you think? Vx equal to what? 5. I didn't give any value here. Just look at this. We have a voltage source, yes, and then yeah, and then this one will have a current, right? Current will flowing through R1, and when this one flows through R1, there's some voltage drop across this, right? So it's supposed to have the same voltage as the Vs because we don't have any other load. If you have another load like R2 here, then there's additional voltage drop across R2. Like this is V2. Oh, sorry, this is V2. So since we don't have this, then only one, then it should have the parallel value of the one, yeah, in parallel. So yes, thank you all. Yes, the answer is Vs. Okay, good. All right. Okay, let me zoom this one. So if you have this configuration on your right side, V1 and V2, you're supposed to have exactly the same value as this V1 and V2. They should be equal to each other. But yes, in your ideal case, in your circuit class, yes, you can put the configuration as in parallel like this. But this is not a good way to do in your real world, because why you learn circuit? It's not because of the theory, right? It's the theory is your knowledge, but you're going to apply in your real world. So in your real world, please do not connect like this. Why? Because V1 or V2, if V1 is equal to 5 volt, it has the additional plus minus 0.1, right? It will not give you exactly 5 volt. Maybe this one 4.9, and maybe this one 5.01, something like that. In your real situation. So they are supposed to be equal, right? 5.01 is not equal to 4.9. So something bad will happen to your circuit. So this is not a good way to configure your circuit. Then this one should be avoided. Please do not do this. In parallel, you should not connect both voltage source in parallel. Okay? So far so good. All right. Second, we have ideal current source. Same as your what we call this, voltage source just now. Now we have a current source. Current source maybe here equal to 3 amps. Ideally, yes, it will give you 3, exactly 3 amps. But in your real life, you will not see this. You need to plus minus with some value, right? You will get maybe less than that. So in real situation, you will not get 3 amps, but ideally, yes. So if you look at on your left side here, if this is a 3 amps, okay, 3 amps here, then you're supposed to deliver this source of 3 amps, right? Over here, 3 amps. And then entering this I1 source here should be also 3 amps. So over here, since this is a source, you should have a source of 3 amps, right? And then the delivering of this should be also 3 amps. But what happened in your real life? What happened if you put this is as 3 amps, but suddenly, yes, you have a plus minus of 0.01, let's say. And then this one will not be 3 amps, but eventually this one you try to give a 3 amps. But now this one is less than, maybe this is 2.9 amps. And then suddenly, even though you put it as a 3 amps as your source of I1, but now this one may be 3.1 amps. Then this and this, they are not equal. It's supposed to have the same in series, right? Series should have the same current. Remember our analogy, the water stream? Water stream should have a same current, I. So this is not a good way to configure. Please do not use current source in series. Okay, not a good way. So what should you do? You can do like this. Put it in parallel. Why? Because if this is 3 amps and another one is also like 3 amps, if, maybe this is not in your real life, it will give you 2.9. Sorry. Okay, someone wants to enter, because if I didn't minimize our slide here, the student cannot enter the class. Then you will be left outside. All right, now if you put it this way, then these 3 amps, this 3 amps coming from here can be plus with 3 amps here. Even though both maybe will give you in real life 2.9, this is maybe 2.89, then these two can be combined at this point. And then this is the I total. Okay, so meaning to say in parallel you can add the current, both current. Okay, and then that's why you will get I1 plus I2. Yes, we are ignoring the direction of the current. We just assume that the current is positive going up. Okay, and since both are positive, then you are safe. You can just plus. If this is going down and this is going up, then this is a plus, this is a minus. So you should have I1 minus I2, because why? I1 plus minus I2, something like that. Okay, just to say, to let you know that in parallel you can add both. So far so good. So in real life, it's okay to put it this way, because why? Even though you have less than 3 amps, okay, less than 3 amps, you still can add both. So the configuration is safe. All right. Now this one. What is a resistance? By equations, this is the resistance. All material, you need to know that all material resist the flow of current by R. Meaning to say, in all of your material, any materials, they have their own R, less or more, okay? But they have their own R. Even the wire have their own R. But maybe the wire we have in the lab is very small R, which is equal to R equal to 0. So all material have their own resistance, including like resistor, yeah, because that's resistant, and then capacitor, inductor, anything. Okay, dia masuk tak? Yes. Right. Now, what is R? R is equal to resistivity into the length of the material divided by cross section of that area. So everything is in ohms and meter. Make sure this is in meter. Yeah, area is a meter square. So if you have something, a material like this is a wire, then you have a area of this and the length here, and some resistivity of that material in ohms meter. So this is one of the condition. Okay. I think this one you are familiar with this Ohm's law. Voltage is related to IR, or we put it as a directly proportional to the current. And then this one, if you look at the voltage versus current, if you plot voltage versus current, then the slope here is your R, the R value or resistance value. And you still remember, right? If you have before that, maybe I should recap your knowledge. What if we have, last time I said we have two types of materials, right? Elements, which is, anyone? Active, okay, thank you.
Passive.
Another one, passive, yes, good. So we have active and passive. One is active, another one is passive. The active element can be what? Anyone?
Battery.
A battery, voltage source, current. And for both, you have your own, like one is independent source and another one is dependent source. And yes, and another one, the current source, you have independent source and dependent source. Okay, I just put it this way. This is a voltage source and this is a current source. What is passive element? Any example?
Capacitor.
Yes.
Resistor.
Capacitor.
And?
Inductor.
Yeah, good. So we have these three. And what is passive sign convention for passive element? If I put it this way, the current is entering what? For passive element. What polarity we have?
Positive.
Yes, positive. And leaving this junction should be a negative. Same. You just look at what? Current direction. If I put current direction like this, and then the current should be flowing into this capacitor and leaving is a negative. I will keep on repeating this because this is very important and somehow some of you forgot. Okay. And what about this source active? What is current direction? Current is entering what?
Negative.
Yes, current should be entering a negative and leaving a positive. Okay, that's good. Okay, at least you still remember what elements we have. Okay, so for Ohm's law, we have this, and then if you look at here, the current should be entering a positive of this passive element. And for this one, the Ohm's law only applies for linear part. And then we don't have a non-linear. For at least for your circuit class, you should have this, okay, linear. And if you look at here, we have a positive linear and also this one, the negative side, okay. yes, we may have a positive R and also we may have a negative R. But later on, maybe if we have that example, then we can look at the negative resistance. But yes, resistance can be negative. Okay. Right. This one, I already give you the example. Yeah, this one. If we have a positive, something like this, then we have this R is too small such that it approached zero. Okay. And then what happened to the current flowing through here?
Bigger.
Can it flow through this R or not?
Short circuit?
Yeah.
No.
R will becomes like a short circuit. Yes, it's a short circuit. And then, yes, I may replace this one as a short circuit. And then current, yes, it will flow through this. But remember, this is not a good way to configure your voltage source. The voltage source cannot be connected to a short circuit like this. Why? Anyone?
Will be
Will be?
decreased.
The voltage, yeah, the voltage eventually will be equal to zero. Why? Because current keep on flowing, and then there's some heat going out from this, and the voltage will be drained out. So if you apply Ohm's law, actually this one coming from V equal to IR, right? And then this R is equal to 0, then V should be equal to 0. Okay, good. And then what if we have a voltage source connected to a huge value of R, such that it equal to infinity, or it approach infinity. What happened to the current?
The circuit will cut off.
Yes, current will this one will be cut off. Why? Because this one becomes like a barrier, a Great Wall of China, right? Then current cannot flow, right? Because there's some open circuit. There's disconnection of this thing. So I will be equal to 0. Okay. This is not a good way to connect your, maybe you have a wet fingers or something, and then you will touch this to here. So this is not a good way, because you're going to be the conductor of yourself. Okay, so you're going to have the current flowing through your body if you have a wet hand, something like that, or you put your tongue at this open circuit. So this is not a good way to let loose the open circuit. Okay, just to make sure that please remember, an open circuit always have a current equal to 0, because later on you're going to face this type of question. This is a very simple question, but later on you will have a huge circuit attached to this, and then they will test you on what is the current at this open circuit. So you need to know that current equal to 0 at this open circuit. So far so good. Okay. Right.
Yes.
That's good. All right. Now we have another thing. Maybe you're familiar with this, conductance. Conductance is the reciprocal of resistance. You just inverse the R. Okay, inverse of R. Then you will get G. And G, the unit is in, before that, we know that ohms is this, right? Ohms. Okay, but for conductance, you will take this as a inverse. This is a unit for conductance, or you call it as a mho, M-H-O, mho. Okay, or you can also write down S from Siemens. So you have the unit is in mho or S. So far so good, right? But you need to know that if you plot this, then the inverse of R is your G, conductance. Okay. Do you get me on this side? This one just inverse of this graph. So if you have I versus V, the 1 over R is the conductance. Okay. All right. Now power. You know that power is equal to IV, and if you apply the Ohm's law, you will get I square R or V square divided by R. But what about this part? If you still remember in our lecture 1, we put that if P equal to plus IV, what is this type of element? Is it absorbed or delivered?
Absorb.
Is it the power is absorbed or delivered? Yes, someone say absorbed. Yes. Okay, you just look at the sign, right? The positive always absorb. For negative, P equal to IV. So this is a delivered. Power is delivered. Okay, but what this one tells you? Macam mana ni? How they conclude this? Why R is always positive? Because it's actually coming from passive sign convention. You have I, you have a plus here, and you have a negative here, right? And then there's some voltage drop across this the R, maybe any value. Usually they put a plus minus like this just to follow the passive sign convention of this. But you need to know that anything that I is entering, you should put the plus sign. So P is equal to a plus sign, and then the I value, okay, and then the V value, okay. If the V value is negative, if this one negative, then you put negative lah. But so far this one is a positive. So that's why they put it, the R is always positive. Okay, power is always absorbed for resistor. Okay, this one already done. The short circuit. When you have R equal to 0, then you will have a short circuit. But recall, you cannot connect voltage source to a short circuit because you're going to drain out your voltage source. Or maybe this is a battery, then you're going to drain out. If let's say you have a capacitor, and then capacitor always charge something, right? Like V of something. This one just your knowledge, your own knowledge. How you going to have uncharged capacitor? How do you do that? Any idea? You? Come again, brother? How, yes, if you want to uncharge your capacitor, you just short circuit both terminals. Then you will drain out this VC will be equal to 0 instantaneously. Okay, capacitor, in fact, capacitor is the application of capacitor is inside the battery. So this is what they do lah. All right, open circuit. Open circuit, yes, you will have R equal to infinity to have that open circuit. And then you need to know that there's no current will be flowing through an open circuit because it's such a very big wall there. Okay. All right, this one. What is this? Okay, the question asks you to find I2. Where is I2? On your left side, right? This part. Okay. If you apply Ohm's law, that I is equal to V over R. Then what is the value for V and what is the value for R? You can write down in this chat box what is the value for V and What is the value for R? Yeah, please volunteer yourself. Sekejap lah. Okay, Afiq says negative 0.5882. Anyone else? Volunteer? And what about R? Why do you say that this is a negative? Actually, I want all to respond, because when you respond, if you make mistake, you learn from your mistake. Why not positive? You know that I2 is going to enter a plus, right? Like your friend here, he said that V equal to 9.4118. Why not 10? And then, yeah, this one 0.5882. Now I confuse you, right? Okay. The answer is, actually I want you guys to respond. Please try to write down something. Okay. Only brothers respond. Where's sisters? Sisters maybe go to dapur, go to the kitchen and then cook something. Okay. Okay. I2, yes, we're supposed to have a plus because of the passive sign convention. But like I said, whatever we have for that value of a voltage drop across that, you just use the sign. Like this one, you have a negative, right? So since even though this is a plus, and we have a negative here, for the voltage, yes, you use the negative sign. So I just erase that one. You have a negative 0.5882 for the value of V, okay? And divide by dr. R is 2K. Okay. So anything you divide by K, you will have a milli of something. So this one you can use your calculation. But please do not write down in your equation the unit like this one, V. No V, no ohms. This one wrong. Please just write down the value. For your final answer, yes, you may put the unit and prefix. Do not forget the prefix. Sometimes students forget this kilo. So please do not forget the prefix. Okay. Yes, sister tengah khusyuk. Okay. Taking notes, right? Yeah. It's good to take notes, but I think you can go through the video. Okay. Then next, V6. Where is V6? V6.
Madam,
Yes.
kita bahagi sekali dengan 2 ke kita terus jadikan 2K tu?
Yes, 2 kilo.
Bahagi terus 2?
Yeah,
Tak payah 2,000?
That's the problem faced by many students up until now. Okay, kejap. Right. Let's say we have 2K here, right? 2K.
Okay.
Usually, I want you to use kilo or prefix. If they put the sign of milli, then you use milli. Milli, kilo, pico, nano, femto, anything. Please use that prefix. Why? Because you have your calculator, right? And you can use your prefix sign. How to use that? If you have your calculator, you can put a shift sign and then you just press whatever the one you want, right? So do not waste your time to put 0, 0, 0. You will lose your time just writing down the 0, 0, 0. And then, yeah, try to avoid that. And by the way, if you have kilo here, what I always did is when you have a kilo, then you know that your answer will be in milli. Milli, milliampere. There's some call here. Tak apalah. Not important. Okay. Now, this is milli, right? So what should you do? If you have your calculator right now, you press 0.5882 divide by 2. Don't put the K because K already put here as a milli, right? Are you okay?
Yes.
Yes.
Okay, so this is the fastest way. You just ignore this, not ignore because you already put in the answer. Just do not forget the prefix. So try your best not to use 2 the power of 10 of 3. No, I don't want this. No. Please write down in terms of kilo. Okay. And if you forget this one, the answer will be wrong. I have no compromise of this. If you don't have this, wrong. Okay, I will not give you half marks because of this is correct. Even though this one wrong, it's also wrong. Unless you're going to take this whole answer to another question, yes, I will give you some points. But in order not to make this silly mistake, okay, this is not a silly mistake. Sometimes you confuse. You try your best. You write down the equation because sometimes if you make mistake here, I will look at your equation. Equation always give you some marks, like half marks or something. Okay. This is my way of marking your paper. Okay, so that's the one of the way lah. Right. Any other question? You can write down kalau malu sangat. If you feel shy, you can write down in the chat box. Okay, what is EECE? This one. Apply Ohm's law. Okay. And then what is I? The value of I. You can write down in your chat box. I know maybe some of you already went to sleep. Or are you in your apa panggil? In Mahalah Cafe? Okay. The current is equal to I think because you're fast. This one I don't really want the final answer. I just want for you guys to know what you want to have. So this is a current. Current is entering a positive, right? So this one should be positive, and then the current value is this, right? 1.61 milli. And then what is the R? This one, obvious. So 6K. Over here, you have a milli and K, you can just cancel and then you do the calculation and you get the answer. I think 9.66, right? I think so. Okay, now what is R4? R4 here. R equal to voltage divided by I, okay. Do you think this is a positive or negative? Okay, just write down in the chat box. Yes, someone say positive. Anyone says negative? Okay, good. Why positive? Because current is flowing through this. And then you have a positive because of this, okay? And then what is a voltage? Voltage is this, yes, good. So you have a 13.53 and then you have current value of this, yes, good. Okay, with milli. So if you have milli, then you should have kilo here. Kilo of something. 13.53 divided by 3.38. Kilo of what? Kilo ohms. Do not forget the unit. Unit is ohm. Prefix is kilo. All right, good. Now, next, you have V2. What is V2? Okay. Why did I put a V2 of that direction? Anyone here can say something? Can, yeah, write down. Or you can unmute yourself. Why did I put this direction, not this direction? Let's say I put this direction. Okay, I put this direction. Then what happened? You're going to find V2, right? So V2 is equal to IR. And you know that if this is a current entering a passive element, you should have a positive. Okay. But now what is current value? What do you think? If I follow this, current value will be? Yeah, write down.
Negative.
Yes, negative. But you made a small mistake. Negative 3.38 of what? This, right? Milli. Do not forget milli. So you have a negative 3.38 milli. And then into R, which is 2K. Okay. Then you can cross this one and multiply. You will get the answer. If you use this direction, you will have V2 equal to negative. Why negative? Because of, yeah, it's still positive here. Okay, positive. But you have a 3.38 milli here. And then V2, V2 pula dah silap No. This one should be a negative because of, even though this is a plus, you need to take care of the negative sign. It's supposed to be equal, but since this is not equal, then you take the negative sign. And then 2 kilo. And you will get the same answer. Okay, so far so good, eh? Any question? Okay, what about this part? I8. I8 equal to? What is the V? V equal to? Yes, 10.59 is a positive, right? Because current is entering a positive here and same as this one. And then divide by 8K. Then you will get the answer in milliampere. Okay, good. Okay. For your circuit class, they will use a circuit or networks. What is circuit and networks? It contains any elements, a passive or active elements in your circuit or in your network. So this is the network or circuit. Sometimes they call it as a network, sometimes circuits. So please do not confuse yourself. The terminology is same. Okay, networks are composed of nodes, branches, and loops. So what is nodes? A node is when you have two or more elements. Two or more elements at a single point. They are connected at a single point. So this is a node. Two or more. What if I put something like this? Is this one a node or not?
No.
No.
Why not? Why not? I said a node is when you have two or
Yes.
okay. So if you have two or more elements connected at this single point, you have a node. Okay. All right. What is a branch? A branch is any element. A branch is any element. So if you have active source, then this is one branch. If you have this one as a resistor, this is another branch. So how many branch here in your circuit? How many branches in this circuit?
5.
Yes, 5. Oh, sorry, because I dah tutup. So we have 5. Allah, sekejap. Apa ni? Okay, here. So we have 5 branches. So in our last definition of node, you can define the nodes as if you connect 2 or more branches at a single point like this, then it also a node. Remember a branch is a element. Okay, any branch is any element. Macam tu lah. Okay, what is a loop? Loop is anything that you can have a closed loop. Yeah, something, a closed path. So you have 2 loops, but there's something we call that independent and dependent. Independent and dependent loops. Independent loops is this one. Loop 1, loop 2. A dependent loops, it depends on other loops. So you have another this. You can have these big loops because it's a closed loop, but it depends on these 2 loops, right? So it's dependent loops. Right. For this equation, this one is the dependent loop. Okay, dependent loops. So this one already defined, and let's confirm with the equation. If you have a branch which is equal to a loop plus nodes minus 1. So since we have 2 loops, 2, and then we have how many nodes here? Can you count? Sorry, so many things. How many loops in this? How many nodes? You have 1 here, 2 here, 3, 4. So you have 4 minus 1. 6 minus 1, you have 5, right? So it says that a branch is equal to 5. And you have 1, 2, 3, 4, 5. Yes, you have 5 branches or 5 elements. So this one is just to verify that your calculation is correct. Macam tu. Okay, good. Let's skip this one. I think this one tak nak skip. Tak apa. Okay. Okay, how many nodes we have here? Nodes. Okay, some says 6. Anyone else? 8. Okay. Go back to your definition of nodes. If you have 2 or more branches connected at a single point, then you will have 1 node. Okay, 1 node. Now everyone changed to 3.
3.
Why? Because at A here, yes, you have 1 node. At B, you have how many elements connected at the single point? 1, 2, 3, 4. Yes, 4 elements are connected at a single point. This is one single point, even though you see that this, and this. Okay. And then the last one, same as previous, you have 1 node. So the number of nodes is 3. What about independent loops? Remember, independent loops is the loops that are not depend on other. Okay, so we have only 3. Good. Yeah, majority says 3. Good. So if you have that branches, loops plus node minus 1. So loops is how many loops? Loops we have 3, then plus nodes 3 minus 1. So you have 6 minus 1, 5. Betul ke ni? Ke saya yang salah? Betul-betul. confuse sendiri. So we have 1, 2, 3, 4, 5. 5 elements or 5 branches. So this is correct. Good. And another way to draw your circuit is by like this. This is the same circuit as your previous slide. This one, they're the same. It's just that they put it this one at one single point. So you have B here. So do not be afraid if I give you the question like this, because you're going to see many of your example. The question will be like a box, a circuit. But sometimes I will give you this type of question because my previous student, some say, "Oh, madam, you are unfair because you give me difficult question." Why difficult? Because of this type of drawing. Just because of drawing, then you get difficult question. You know what? You need to understand what is a loop, what is a note. Okay. All right. Now you have this. How many notes in here? I think the most crucial part here is notes. Okay. How many notes? You can write down. Okay. Some say 6. 1, 2, 3. Some say 6. Okay. 4. Lagi. 5. 3. Okay, 3. Majority says 3. Okay, go back to your definition. What is a note? 2. Reduce. 4. Okay, notes is when you have 2 branches or elements connected at a single point. 2 or more, right? 2 or more branches connected at a single point like this. So if you have this, then you will have one single note, including if you have something like this, then this is also one note. Yeah, majority says 4. Where is that 4? You have this, this, this. Baru 3. Where's another one?
Between 3 and
5 ohm.
Yes, in the middle, right? Here. Okay, you can see, right? There's 4. So there's 4 nodes. And how many loops? If there are loops, it means that dependent and independent. Okay. Tapi I usually consider independent loops. So this one should be 4. But what if loops? Loops of independent and dependent. How many? How many loops? If we combine both. Independent and dependent loops. You have here 4. 1, 2, 3, 4. Then lagi loops. Loops of independent and dependent. 6. Okay, some say 6. Okay, 4, 5, 6. But you still have in the middle 6, 7. Okay, 7 lagi. 7. And then 8. Then 9. Right. And then 10. Yes. Good. Okay, good. So we have 10 loops of independent and dependent. How many branches? Branches, straightforward. You just calculate 1, 2, 3, 4, 5, 6, 7. So you have 7 branches. All elements in the circuit. Okay, good. All right. Now Kirchhoff. We have Kirchhoff current law and Kirchhoff voltage law. Okay. And this one will tell you how the voltage and current are related within a circuit element. Okay. Let's say, we have the current here. The current is entering and current is leaving the nodes. Something like this. Okay. So Kirchhoff current law, it says that the summation of all current at one node should be equal to 0. The summation of all current entering or leaving the nodes here will be equal to 0. Okay, or we can put it this way. The summation of current entering should be equal to summation of current leaving. Why this is a positive? Can you guess? If you look at, if you say that entering is a positive, entering this node a positive, then leaving the node should be negative. Okay, so if this is a positive, a plus sign, and this one is a negative sign, then the summation of all here should be equal to 0, right? And if you bring this negative to here, you will get a positive sign, just that. So I usually will take care of, I will consider on this part, not this one, because this one will confuse. So current enter should be equal to current leaving of that node. So like in our example here, you will have this current enter. This one will be leaving. So you have 3 enter. So I1 plus I2 plus I5 equal to I3 plus I4. So far so good. That's why they get this. If you want to apply this, yes, you may, but please observe the polarity, the sign. Okay, now it's 12:30. Do you want to stop here or we just finish until 12:50?
Finish.
Finish?
No. Sampai habis.
Okay, Alhamdulillah. Right. There's another point on the current Kirchhoff law. Like we said previous, we have at nodes, right? At nodes. But right now, we have another thing. We say a boundary. So actually, in your circuit class, later on you will face some boundary condition. So if you apply boundary condition, you need to know that anything attached to this boundary, you will have a current entering and also current leaving that. Okay, maybe this one, this 2K, you have a current flowing into the boundary, right? For this 2K, you have current leaving the boundary. And for this part, entering the boundary. This one, leaving the boundary. Anything attached with this part, then you need to consider all. So current entering boundary should be equal to current leaving the boundary. Okay. So since you have that, then which one is in entering the boundary? Can you see? Which one is entering boundary? Which one? I1 and I3, yes, good. I1 and I3 should be plus together because summation of all current entering should be equal to summation of all current leaving. So you have a I2 plus I4. So this is an equation. And if you rearrange, yes, you can get this. So it's same. Okay, now current Kirchhoff. For this one, still that one. Okay. What is ascension nodes? Ascension nodes is when you have 3 or more branches connected at a single point, like this. You have 1, 2, 3. You have 3 or more branches connected at a single point. This is essential node. Okay, essential node. They just put the word essential. Essential means many. So how many essential nodes we have in our circuit here? 2. Some says 2 because why? Because I think they put a red dot here. But do you think 2? 3 3 or more branches connected at a single point. So you have another one here, right? What about on the right side? Here. Is this a ascension node? No, yeah, no. This one, no. This one also no. Only 3. So what is the ascension node number 1, 2, and 3? Any volunteer? You can write down the answer in your chat box here. Okay, number 1 first. Cepat. Kita nak pergi makan ni. What is equation for KCL at the first ascension node? Right how? Write down in the chat box here. Okay, I will give you the first example. Number 1. Okay. This is current entering. This is leaving, and this is also leaving the node here. So the current entering is I1 equal to the summation of current leaving. So I6 plus I8. So far so good. This one? Or you still confused? Yes, okay. What about at node 2? Right. Okay. Node 2. Yes, I6 plus 5 milli equal to I3. Yes, this is correct. What if you put I6 plus 5 equal to I3? Is this correct? No, right? Why no? Because there's no milli here, no prefix. If no prefix, then wrong answer, okay? So kita dah sehati sejiwa, kita dah letak we need the prefix. We need the prefix. So if you give me without the prefix, I will give you wrong. Yes, good. Okay, what about note number 3? Ascension note number 3. Okay, you can write down the answer. I think all of you should write something. So that we can check whether our assumption is correct or wrong. Maybe you need some space, right? I just remove and remove. Okay. Okay, some says I8 plus 5K and then equal to 10 plus 5 milli. Oh, by the way, if you look at this sign here, this is KCL, right? The C in the middle here stands for current. So what should you do? You should look at in the circuit only the current. Okay, only the current. So if you put 5K here, this is not current. This is resistor. So what should you do? You find the current flowing through 5K. Like this one. What is the current through 5K? The I3, right?
I3.
This one flowing through this. So this is the I3. Okay. I3 plus I8. Okay, good. Then this one leaving, right? Leaving. This one also leaving. This one entering. This one, I just want to test you on series and parallel. Remember, series is anything in side by side. Means if you have two elements side by side like this, then this is in series. What is parallel? Parallel is when you have a circuit, maybe something like this. You're connected end to end, at this end to end. They are all in parallel, okay? Maybe you have two, but still they are connected end to end like this, then they are parallel. Okay, good. Now the answer is Betul. Yang I8 plus I3 equal to 5 milli. Don't forget the milli. And then plus with I1. Okay. This in series. This in series. Okay. That's good. Tapi kenapa dia ada another... ni betul lah. Betul-betul. Alright. Kirchhoff voltage law. It states that the summation of all voltages, okay, the name says KVL. So in the middle voltage, it should be all voltages. You sum up all voltages around a closed path or a loop, then it should be equal to 0. Summation of voltages in a closed loop equal to 0. Don't forget the closed loop. And this is based on the conservation of energy. Alright, what is, okay, apply KVL to each loop in the circuit. Okay, this loop. Anyone? Okay, I give you some example. Number 1, if you look at here, anything you see the polarity, you take it as the sign. So this is a negative 10. And then you go, the current, this current is the virtual current or imaginary current. So this current will be seeing this negative V2, and then the current will enter this positive V8. It should be equal to 0. But please make sure this is a voltage source. Okay. Right, this is number 1, KVL number 1. Number 2, in the middle. Okay, anyone? Okay, you start with V8. Okay, negative V8, yes. Minus V6, yes. Plus V8, VI. Another thing, you forget this. Okay, that's why I suggest you guys to write down your answers. Then we can find the any correct or wrong things that you did, right? So we will learn in the from the correction. So from the mistake. So this one, do not forget equal to 0. Yes. The answer is negative V8 minus V6 plus VI equal to 0. What about the last part here? Actually, not last part because they ask you to find loops. Okay, this one? Negative VI minus V3, yes, and then plus V4. Yeah, correct. Most of you got it right. What about if I put this one? Start with this. Okay, this is number 1, this is number 2, number 3. Okay, for this part. Start with negative 10. The outer loops here. Remember, loops consist of 2, right? Independent and dependent. So the one you make, you just build this equation is for independent loops. So now, what if I have the outer loops? Anyone can suggest your answer here? Okay, negative 10 minus V2, yes. Minus V6, yes. Minus V3, yes. Plus V4 equal to 0. Yeah, correct. Very good. Okay, thank you, volunteers. The one they give the loop 4 and loop 5 is coming from this part and also this part. So you can just go through the answer. And I think, do we want to go through this practice or we just stop here? Or do you have any question before we stop? Brothers and sisters? No, eh? Already hungry. Hungry, right? Doctor, are you gonna upload the recording? Yes. In fact, the previous one also there in the Google Classroom. So it's just that I need to upload in the YouTube first and then convert that file. Yeah, and then I'm going to share you the link, inshallah. All right. Okay. With that, any other question? Are you guys in the Google Classroom or not?
Yes.
I hope so. Please, please use your full name, because sometimes if you put your nickname, and then I cannot identify you, and then I give you 0. Okay. So thank you all. With that, we finish our class with Tasbih Kafara and Surah Al-As. Subhanakallahumma wa bihamdik. La ilaha illa anta. Astaghfiruka wa atubu ilaik. والعصر إن الإنسان لفي خسر إلا الذين